Good morning and welcome. My name is Mr. Wagner. I'm inside your computer currently. I'm going to talk about Algebra 2. Let's get started on the good stuff. This is my Algebra 2 page. This is going to be a 5.8. This is the last section that's going to be on your test. Your test is scheduled to be Wednesday. Make sure we write this down. We always like knowing our test dates. Wednesday, October 7th. Wednesday, October 7th. There's a test. There's only going to be 3 of these throughout the year. So this is a big date. We need to know this. This is huge. Huge. Test date. Wednesday, October 7th. Be prepared. This is the last section. It's going to be on there. Let's hop to it. We're writing and modeling with quadratic equations. This is what we'll be doing today. Basically, we're going to take different forms, standard form, vertex form, intercept form, and manipulate them to get other forms. As you may remember, standard form is in the form y equals ax squared plus bx plus c. This could be something written as, for example, 2x squared minus 3x plus 10. We call that standard form, where your biggest term degree x squared's in the front, and it goes down to your linear term and then your constant term. Vertex form, we love graphing in vertex form. It makes things incredibly easy. Right, your h comma k is your given vertex. H and k give you the vertex. We love graphing in this form. Right, if I had x minus 2 quantity squared minus 1, my vertex would be at 2 comma negative 1. That's my h comma k. Lastly, intercept form, or factored form, if you will. Right, if I had 2 times x minus 3 times x plus 1, this p and this q, these are my intercepts. These are my x-intercepts. So x equals 3 comma negative 1. Notice that once again, it's what value makes it 0. Positive 3 makes this 0. So that's why positive 3 is an x-intercept. Negative 1 makes this factor 0. That's why negative 1 makes that intercept. And once again, lastly, the a value for all 3 of these are always the same. A is the only value that does not change. And a in standard form is the a in vertex form is the a in intercept form. Let's hop to it. So, some examples you'll be seeing. Write the quadratics in standard form. This right here is intercept form. My 2 intercepts are x equals negative 4 comma 9, if I were to graph that. It's concave down because my a value is negative 1. That's my a value right there. It's a frowning face quadratic with x-intercepts of negative 4 comma 9. Now, when it asks me to put it in standard form, I need to do something. And what that something is going to be is we need to convert it from intercept form to this form. Standard form is ax squared plus bx plus c. What we need to do is distribute. Right? We just need to multiply this out. Because there's operation implied right there is multiply it out. Now, whenever we're multiplying these out, make sure that negative sign, this guy, wait until the very end. I'll show you why. Do not distribute that negative sign into it yet. And put your parentheses around the whole 4 terms. X times x is x squared. X times negative 9 is negative 9x. 4 times x is positive 4x. And 4 times negative 9 is negative 36. Very nice. Now we're going to combine these 2 terms. Negative 9x and positive 4x give me negative 5x. Then lastly, now we distribute the negative sign. The reason why I always like waiting to the end is because, first of all, this is just an easy flip. You flip every single sign. X squared becomes negative x squared, negative 5x becomes positive 5x, and negative 36 becomes positive 36. This is standard form because we're in the form ax squared plus bx plus c. My a value is negative 1. My B value is 5, and my C value is 36. Very nice. We continue. Now we're going to change this one into standard form. This is in vertex form. My vertex right here is the point 1, comma 8. There's my 1, that's my H value. There's my 8, that's my K value. My A value is 3. This value right there. Once again, I'm going to distribute to put this into standard form. It's going to look a little bit different, though. I'll show you why. X minus 1 quantity squared, leave the 3 outside, write the x minus 1 twice. Everything else I wrote down the exact same. The plus 8 stays at the very end. The 3 stays up front. Do not multiply that 3 in now. Turn the x minus 1 squared into 2x minus 1s and distribute those x minus 1s. And leave the 3 up in front for now. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. Boom. Make this 3 into the red 3 just because I like things uniform. Distribute that first. We're using PEMDAS. The reason why this goes first, we could technically multiply the 3 in, but a lot of times what happens is there's multiply the 3 too many times. Just keep it out front for now. After that, combine these two terms in the middle. Negative x and negative x become negative 2x. At this point, now we distribute the 3 to all 3 terms, which you get 3x squared. 3 times negative 2x is negative 6x, and 3 times 1 is 3. The plus 8's still there, still lingering outside. Don't touch anything on the out that's being added until the very end. Luckily, we are there. 3 plus 8 equals 11. Very nice. That is my standard form. Ax squared plus bx plus c. A value is 3. B value is negative 6. And C value is 11. Very nice. We move on. Here, we are tasked the tail. So now we're going to look at a graph and write the quadratic function in vertex form. Now, you'll be given questions like this, and every single time do it in this, write down in this manner. It would ask you for in vertex form, write down what vertex form is. A times x minus h quantity squared plus k. Luckily, if we're given the vertex in vertex form, we already know 3 of my unknown values. Right? When you're solving for vertex form, there's 3 things we don't know. We don't know a yet, we don't know h yet, and we don't know k yet. Luckily, if I'm given the vertex, 3, comma 2 goes right there. We know that, so we can plug it in. Y equals a. We don't know a yet. We'll go back to that. H is 3, because my x value of my vertex is 3. Can add 2. My k value is 2, because the y value of my vertex is 2. Now this, we're not done. We need to solve for a. A is basically the constant in which this quadratic grows. Now, at this point, what we do, we take a point from my graph, plug it in for x and y, and use that point to solve for a. So when I'm looking at this right here, notice I have to pick another point that's on my graph. Right? Don't use your vertex. Your vertex is a point, but you'll notice when you plug in 3, 3 minus 3 is 0. That turns 0 squared to 0, and 0 times a is 0. All of a sudden, while it makes the equation true, it does not give you the a value. You can use other points. You can use this point. This point is 4, comma 3. You could also use this point. Any point that's nice and exactly on the graph, crosses the crosshairs of a coordinate, you can totally use. You can also technically use these points up here, but we like our numbers nice and small. 2, comma 3 looks perfect. right? This is 2 spots over and 3 spots up. So we're going to plug in 2, 3. The x value is 2, so I'm going to plug that in for x. The y value is 3, so I'm going to plug that in for 3. And then you're going to solve for a. So y is 3, because I'm using my 0.2, 3. You could have also used 4, 3, but like I said, smaller numbers in general are always better. X is 2. Just like that. We plugged in x equals 2 and y equals 3. And now we just simplify. 2 minus 3 is -1. -1 squared becomes +1. That turns into 1a times 1, which a times 1 is just a, so you don't really need to write that. So if I tell you 3 equals a plus 2, we're right there. Just isolate a by subtracting 2 from both sides. 3 minus 2 is 1. Very nice. So because a is 1, h is 2, k is 3, or no, h is 3, k is 2. This 1 value goes right here. That becomes my final answer. My vertex form of this quadratic is 1 times x minus 3 quantity squared plus 2. Because that's my vertex, 3, 2. My a value is 1, goes right there. You don't technically have to write 1 value right there. For example, you could just go like that. That gives you the same exact answer. Right? We don't have to write down multiplication by 1 because it's just assumed. Nice. We move on. Next is, right, it asks us to write quadratic function vertex form. We're going to use the same steps. We want to write it in this form. This is vertex form. Y equals a times x minus h quantity squared plus k. My k's are just ridiculous. I'm sorry, my k's look awful. Sometimes my handwriting leaves much to be desired, but I'm always trying to become better. Luckily, once again, we are given a vertex. When you're given your vertex in vertex form, make sure to plug in your x value of your vertex into h, your k value of your vertex into the y coordinate of your vertex. Those values go right there. That becomes y equals a times x minus 1 quantity squared -4 goes right there. Now this is concave down. We know our value for a is, when we solve for it, it's going to be negative. But let's see what exactly it's going to be. Once again, we have to find out another coordinate, to choose another coordinate that's on my graph. That's a nice point that crosses over exactly. Boom. Those are 2 points that we would totally use. If we use this one, for example, it's 2 over 1, 2, 3, 4, 5, 6, 7. This point is 2, -7. We're going to take that 2, plug it in there. Take that -7, plug it in there. You could have also used that, but I'm going to stick with 2. 2, -7. And then we solve. -7 goes in for y. A goes here. 2 minus 1 squared minus 4. Now we're using the graph to help us solve for what the vertex form is. Because all the graph is just an infinite amount of listed points that are on my graph. If we know the x, y for one of my points, we could use that point to find out the a value. Solve. 2 minus 1 is 1. 1 squared is 1. And a times 1 is just that. That stays as a. If a minus 4 equals negative 7. We're going to add 4 to both sides. You're going to get A is equal to negative 7 plus 4 is negative 3. Take that A value and put it in right there. And that is my vertex form answer. Very nice. And move on. Write the quadratic and intercept form. Once again, this is very similar to exercise we just did, except intercept form looks like this. Intercept form is y equals a times x minus p times x minus q. P is an x-intercept. Q is an x-intercept. It doesn't matter the order in which you put them down. What does matter is that it's the opposite value of whatever your intercept is. So looking at my graph, I can identify x-intercepts. One of those is right here. One of those is right here. You want to use those to plug it into my intercept form. 1, 2, 3. This one's negative 3, comma 0. This one's negative 4, comma 0. We plug those in. And when you do plug these in, watch this. It's x minus negative 4 and x minus negative 3. Notice what happens. My q value or p value, doesn't matter which one's which, is negative 3. This p value is negative 4. When you plug in a negative 4 to the equation, it becomes x minus negative 4. When you're double subtracting, that turns into plus, 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 plus. That's why these always look for something that may look like a positive intercept, because it says x plus 4 is actually x plus 3 and x plus 4. Those are negative intercepts because minus minus becomes positive. From there, we need to solve for A. Luckily, we're going to look towards our graph to get some valid points. One thing I see right here, right away, this right here is a valid point. You have to make sure you write down what the point that is. You could have also used this one over here. You cannot use your intercepts. Do not use your intercepts because it will just give you an output of 0. This point right here is 1, 2, negative 2, comma 2. So negative 2 is my x, comma y, negative 2, comma 2. So every time I see a negative 2, I'm going to plug in for x. And every time I see a y, I'm going to plug in positive 2. So that becomes positive 2, because that's my y value of the random point I'm choosing, equals a times negative 2, because I chose negative 2 for my x value, negative 2 plus 4 times negative 2 plus 3. The x value using twice because it's an intercept form. And we're not squaring anything in intercept form, but we have 2 separate x values. At this point, we simplify. 2 equals a times negative 2 plus 4 is 2. Negative 2 plus 3 is 1. 2 times 1 times a is 2a. And if 2a equals it, you divide both sides by 2, a equals 1. You take that value, you plug in it right here. My final answer is y equals 1, which I'm not going to write the 1, because you do not have to write 1 when you're multiplying it. X plus 4 times x plus 3. Nice. We move on. Lastly, this one, write the quadratic and intercept form. A times x minus p, x minus q. We are given our intercepts. This is negative 1, comma 0. 1, 2, 3. This is negative 4, comma 0. Use those points to plug them into your p and q value. Y equals a x minus negative 1, that's going to be plus plus. X minus negative 4, that's going to become a plus plus. What that turns into is a times x plus 1, x plus 4. When you have two negatives in a row, it becomes positive. Plus plus, plus plus. This point, we need to choose a point. Any quote-unquote nice point that's on that crosses my crosshairs, and use that point to find your a value. This one right here looks good. You could also use this one. You could actually also use this one down here. We'll use the y-intercept this time. The y-intercept is when x equals 0. So 0, 1, 2, 3, 4. 0 comma negative 4 is a point on my graph. So every time I see x, I'm going to write in 0. Because I'm going to use this 0 comma negative 4. You can, once again, use whatever value you want. That's a nice point on the graph. Negative 4 for y, plug it in and solve. So y equals, negative 4 equals a times 0 plus 1 times 0 plus 4. Because we used 0, that makes the problem very nice to operate with. Simplify. Ooh, what's it going? No, what's happening? Simplify. Negative 4 equals a times 0 plus 1 is 1. 0 plus 4 is 4. 4 times a times 1 is 4a equals negative 4. Divide both sides by 4. A is going to be negative 1. Plug that negative 1 right here. And that's my final answer. Now you can leave a negative 1. You can also just rewrite it as negative. What you could write is y equals the opposite of x plus 1 times x plus 4. And that is intercept form. Very nice. We move on. Lastly, write the quadratic in standard form. So we're going to use the same exact method we have been doing, except once we put it in either vertex form or intercept form, we are then going to distribute. So we're kind of combining the very two techniques we learned today. You can totally do this either way. What I see right away is if I'm given intercepts, I want to use those intercepts. Right? We can use intercept form if we're given it. So once again, we need to write in standard form, but I'm going to use intercept form and then distribute to get into standard form. Because standard form, you can't see A, B, or C on your graph. Right? These are values you don't necessarily see. But what you can do is put in intercept form and simplify. So my intercepts are 1 and 3. X equals 1 comma 3 are my two intercepts. Plug that in for P and Q. What it turns into y equals a x minus 1, x minus 3. Once again, those are positive intercepts. That's why it becomes minus. From this point, we have to find another value we can plug in for x and y, so we can solve for a. This guy right here is perfect. It's a nice value. It's also my vertex. We could have used vertex form to solve for this, but 2 comma 1 is a point, which means every time I see x, I'm not going to write x. I'm going to write 2. And every time I see y, I'm not going to write y. I'm going to write 1. And we solve. 1 equals a times x, which is 2. 2 minus 1 times 2 minus 3. What that becomes? 2 minus 1 is 1. 2 minus 3 is negative 1. A times 1 times negative 1 is negative a. And if negative a equals 1, a divided by negative 1 divided by negative 1, a is negative 1. Boom. You plug that answer up here. What you get? Y equals negative 1 times x minus 1 times x minus 3. Boom. Very nice. Oh, woo-hoo. We're going to put it in standard form, so definitely not done yet. Standard form, we need to distribute. The way I'm going to distribute this is make sure to go. We would be done if we want to put an intercept form, but we are going to distribute. So kind of do the very first thing we did in this class. X times x is x squared. X times -3 is -3x. -1 times x is -x. -1 times -3 is +3. That negative sign stays outside. Do not multiply that in yet. -3x minus x becomes -4x. At this point, now you distribute that negative sign to every single term. Every single term becomes -x squared, -4x becomes positive, and +3 times -1 is -3. That is standard form. Your A value is -1, your B value is 4, your C value is -3. Very nice. And move on. The last one for today. We're given a function or a quadratic function. We got to turn it into vertex form. We cannot use intercept form because these don't look like very nice intercepts. You don't know the exact number, you cannot use those intercepts. However, we can use vertex form, which is a times x minus h quantity squared plus k. Use your vertex to get your value. My vertex, 1, 2, 3 over, 3 over and 6 down, is -3, -6. So that means I'm going to plug in -3, -6. X minus -3 squared minus 6. When you're subtracting -3, that becomes plus in the middle. Boom. At this point, we choose a point, any point, to solve for x and y. I'm going to use this one right here, just because it's looking like a really good point. What that value is -2, -5. Plug it in for x and y. -5 goes in for y. -5 equals a times -2 goes in for x. -2 plus 3, quantity squared minus 6. Simplify and solve. -2 plus 3 is 1. 1 squared is 1. And 1 times a is just that. Just a. At this point, add 6 to both sides. To solve for a, you're going to get a is equal to -5 plus 6. There's 1. We like 1. That goes up here. Make sure at this point we're going to have to still put it in standard form. No, we don't need that 1 there. We plugged in a for 1. I'm going to erase it real fast. Y equals x plus 3 times x plus 3. I'm writing it out twice just because I'm going to distribute. Make sure, do not just square x and 3. Write it out twice and then distribute. X times x is x squared. X times 3 is 3x. X times 3 is 3x. 3 times 3 is 9. Now, technically, there's parentheses around here, but since we're not multiplying it by anything, we don't really need those. Combine our two terms in the middle. X squared plus 6x plus 9 minus 6. Make sure that minus 6 stays until the very end, at which point 9 and -6 become +3. And that is the final answer. My A value is 1, my B value is 6, and my C value is 3. Very nice.